Hello, my name is Brian Kauke, and today we're going to discuss redox reactions. It is discussed in Chapter 5, namely oxidation. Redox reactions stands for reduction oxidation reactions because elements are reduced and oxidized throughout the reaction. So we are going to balance this reaction, which is Fe plus permagnite yields Fe with a charge of +3 plus manganese +2 in an acidic solution. So to do this, we have to split it up into half reactions. So first, our half reaction is iron, which yields into iron plus F3. And to do this, this must lose electrons. Therefore, we add 3 electrons here. And also, that means that this is the oxidized half reaction, because electrons are on the right side, which means it loses electrons. Therefore, it is oxidized. So now we're going to do the permagnite, which is MnO4 negative yields Mn plus 2. So in order to do this, we must first make the net charges about equal. So in order to do this, obviously this is -1 net charge and then +2. So obviously that's mistaken. So in order to do this in an acidic solution, what we do is we always add hydrogen ions. And in this case, we're going to add 8 hydrogen ions. And this is because 8 ions, because the hydrogens and the oxygens always have to yield into water. Since there's 4 oxygens over here, we want it to yield evenly with water. So what will occur is that these hydrogens and oxygens will actually combine to form 4 water molecules. And here that means that since this side has +2 and this side now has +7, we must add 5 electrons. And this also means that this gains electrons, which means that it is reduced. Also, you can tell it's reduced because electrons are on the left side. Okay, so that is it. And now that the coefficients of the electrons are not the same, the top one has 3, the bottom one has 5, we are going to multiply the top one by 5 so that the amount of electrons are the same, so that when we add these half reactions, the electrons will cancel out evenly. So we multiply each reaction, so that would yield 5 iron, and then 5 iron, +3, and then 15 electrons. And then on the bottom, we would have 15 electrons. 8 times 3 is 24, so 24 hydrogens plus 3 permagnites yields 3 Mns plus 2 plus 12 water molecules. Now we just combine each reaction. So we have the 15 on that side, the 5 iron, 24 hydrogens, the 3 permagnites, and then the 5 irons with a net charge of +3 plus 15 electrons plus 3 Mn plus 2 plus 12 waters. And although this doesn't look clear, as you can see, 15 electrons on each side, they cancel out, nothing else cancels out. So now we're going to write the final product, which will look something like this: 5 irons plus 24 hydrogen ions plus 3 permagnites yields 5 irons with a net charge of +3 plus 3 manganese plus 12 waters. So to make sure everything, you can't see that. So here I added the half reactions, combined it into one. Over here, this is the final product, and you can see that on each side, the net charge on this side is 24, and then minus the 3, so that's 21 net charge. And this has a charge of 5 times 3, which is 15, and then 3 times 2, which is 6. So that has a net charge of 21. So each side is equal in terms of charge, but the mass is also equal. There's 5 irons, 24 hydrogens, 12 oxygens, and then 3 manganese and 3 manganese. So as you can see, everything is balanced, so we did this correctly.